Right on page 1. It says the amount of waste at a junkyard is changing at a rate modeled by W of T, measured in tons per day. Initially, there are 20 tons of material in the junkyard. So what do good habits say we should do always first step for these kind of situations?
Set up the problem.
Set up the problem. Let A of T, because they gave you a rate, just a general rate function. Let A of T be the
Amount of waste at a junkyard at
thank you.
time t
Thank you. The amount of waste in the junkyard
times.
at time T, measured in tons, so that A dash of T is
The rate.
W.
W or R of T, which is the same as W of T here. It's the rate of change of the amount of waste at time T. And that is measured in tons per hour, is it? Tons per day, sorry, tons per day. Right? And then the question says, initially, there are 20 tons of material in the junkyard.
A of 0 equals 20.
Miss Faldonava, how are you feeling?
I feel better today.
Okay, good girl. Okay, the question says use a trapezoidal Riemann sum with 3 intervals, okay, to estimate the amount of waste in the junkyard at t equal to 10. If you'll give me a left-hand side and a right-hand side, please. I want to see, interpret the question exactly the way it's written. It's not a trick question. Give me a left-hand side, give me a right-hand side, do that independently. I may pick on one of you. All of you, please be polite. Can you please unmute yourselves? It says estimate the amount of waste at t equal to 10. Mr. Poole, interpret the question literally. So what are they asking for?
It's A of 10 is equal to A of 0 plus.
Stop. That's for somebody else. I didn't want to interpret A of 10. Stop. Okay, Miss Gastelum, how do we find A of 10?
A of 0.
Very, very good. Love you, Gastelum. Guys, be alive. If they give you a seed value, a starting value, use Netchin corollary. Plus, go.
Integral from 0 to 10. A dash of t dt.
A dash of t. That's the Netchin corollary. You take the derivative. Don't say A of t. No, it's A dash of t dt. And A dash is nothing but W, correct?
Yes.
Guys, we're getting ready to approximate some now approximation symbol. Okay, don't write the original guy's approximation symbol. We're doing a Riemann sum now. So A of 0 is given to me
20.
20 plus brackets. We were using a trapezoidal Riemann sum. It's from 0 to 10. So I'm drawing the trapezoid speed. Okay. Guys, keep in mind the trapezoidal rule is average of the parallel sides. So which are the parallel sides? The y values or the x values?
Y values.
Y.
So tell me what to write.
2 minus 1 over 2.
Very good. 2 minus
Times
1 over 2 times 3. Very good. Good. Plus, do the same pattern for the others.
Negative 1.
Negative 1 plus 5 over 2 times
3.
3. And then finally, is that you, Tarango?
Yes.
Look at you. And then last,
5 minus 3 over 2
5
times
minus 3 over 2. Okay, it's the average of the parallel sides, which are the y values. Average of the y's. And then distance between the parallel sides are the x values. 6 to 10, distance is 4. And that's it. Okay, that's the amount, so that we measured in tons.
Yes.
Okay, so I wrote down units. Okay, now we're going to accelerate. Okay, I'm going to accelerate. Go to page 2, please. Okay. Write down this expression. It says estimate that using a left Riemann sum with 3 intervals. Is there a mismatch? Or are we good to go?
We're good to go.
We have WT, and we need WT. We have a WT. We're good to go. Okay, there's no complication. So equal approximately. Bring down the 110. Guys, what I'm doing in class is pretty much what I need on your test and homework, okay? Left Riemann sum. So it's 0 to 10. Let me sketch the 3 rectangle. First base,
3.
3. Hint, left. What's your first left height?
2.
2. Okay. For the first rectangle, for the first left height. Plus, second base,
3.
second height,
Negative 1.
negative 1, the left guy. Finally, third base,
4.
and then left height,
5.
5. Okay. Now stop. It gets trickier. It says interpret your result and then specify units. First, we'll interpret the result. Do not speak. Do not speak. Look at this expression. Which 3 interpretations does this guy remind you of? Do not speak. Is it average rate of change, or net change? And it should match up. It's one of those 3 interpretations. It has a 1 over 10 outside and an integral. So which guy does that guy remind you of?
Average.
Rate of change.
Okay, is the average, do not overthink it, of W of t. So it's the average of, look up in your notes. What did W of t stand for?
The rate of change.
Thank you, love you. It is the rate of change. Again, look up. It tells you what W of t. We wrote down. So Mr. Lopez, can you see? That's why we write down all that stuff. Because Lopez was saying, I'm just telling you a conversation me and Lopez had. He said, Rama, do I need to write all this setup? And I said, Lopez, it's useful because it helps you in the interpretation. All right. You may not think that for a word problem, hey, it's useful. Like, man, I get it. But I'm saying for interpretations, it's useful to have what W of t actually stood for. It is a rate of change of
The amount of
amount of waste in the junkyard. Okay, now stop. Now let's discuss units. Now remember the concept. For the average as well as net change, you just give me the units of the function you see. I see the function W of t is the average of W of t. And what are the units of W of t?
Tons per day.
Tons per day. Okay, it is exactly the unit of that guy. Over the interval 0 to 10 days, so that's measured in days. So I need a full sentence, guys, on your test. You will mimic what we're doing. You will not do your own thing. You'll not write some brief thing. No. It is exactly what we do in class is the AP expectation. Let's do another one. Right on page 3. Right on page 3. It says calculate that and interpret it, specifying units. I'm giving you a tip, everybody. I don't know if you have observed this in your homework. I'm giving you a tip. Look at that first word. Did it say calculate or estimate?
Calculate.
So I'm giving you a hint. If it says calculate, then a Riemann sum is never being used. Because it said calculate. Because if it was an estimate, then a Riemann sum. Because remember, we use Riemann sums to make estimates. This is exactly calculate means we knew the exact value. But stop. Is there a mismatch?
Yeah. Yes.
So we should be able to use net change. If you to use net change, integral of W dash is nothing but
W14
14 minus
W3.
W of 3. Because the integral of that derivative, Ms. Paratha, will cancel. It's an antiderivative of derivative. Okay. Ooh, what's W of 14?
4.
Minus,
Negative 1.
which is 5. Okay. Now let's write an interpretation. Now everybody look at the board. Look at the board. Can you see? I don't know an interpretation of that guy. Let me erase it so it's not getting in the way of your thinking. Okay. Have a look. We don't have any interpretation for that guy. For that guy. There is no interpretation for that guy. But on the other hand, do we have an interpretation for that guy?
Yes.
Which guy does that guy remind you of? Average rate of change or net change?
Net change.
Net change. So it is a net change in W. What does W stand for again?
The rate of change.
The rate of
Thank you. The rate of change. You don't have to overthink it. The rate of change of the amount of waste. The junkyard. And then old rules. The unit for net change and average is just that function, which is W. In
tons per day,
tons per day. Over the interval,
3 to 14
Days.
days.
days. Okay, that's time. And that's how easy that was. I'm accepting any questions or clarifications. So I'm giving you some tips to watch out. It said calculate means, hey, there's no Riemann sum involved. If it said estimate, there'd be a Riemann sum involved. Okay. Last question of this kind, right on page 14. I mean, page 4. Sorry, page 4. Okay, do not speak. Interpret the question exactly the way it's written. Do not speak. Okay, Mr. Guerrero, Mr. Hernandez, or Mr. McCoy. One of you three can answer. You guys are a package deal. Any of you can interpret the question for me. Go.
A of 14 minus A of 0
Love you. It's M set.
over 14.
Very good. Average rate of change. So it says amount. So it's A of 14 minus A of 0 all over 14. Is there a mismatch?
Yes.
Yes, because we have A and W. So can we pull out the 14? 114. Integral from
0 to
0 to
14
14.
0 to 14 A dash of t, which is nothing but
W of t.
W of t. And now we're good. Now it matches. And it says Riemann sum. So approximately, bring down the 1/4. And it says midpoint Riemann sum, guys. So I'll sketch. It says only 2 intervals, Ms. Maratha. So it's 0 to 6, and then 6 to 14. First base,
6,
6. We're going from 0 to 6. Midpoint,
negative 1.
negative mid height, plus second base hit 6 to 14.
8.
8,
8, mid height,
Negative.
negative 3. Now, thanks to you stepping away, Ms. Morales, have you got the hang of the 4 Riemann sums?
Yeah.
How to get them?
Yeah.
Just making sure. All right. And then finally, this is the tricky one, guys. It says mention units. Everybody look at the board. So we did the average rate of change of the amount function. Okay, we did, so in other words, it's an MSEC for the amount function. So you'll give me the slope of the amount function. So what will the slope be? Units.
Tons per
Tons per day. Okay. It's like dA over dt. It's amount on top. Here's another way to look at it. It's amount on top, time on the bottom. Okay, we subtracted 2 amounts on the top, we subtracted 2 times on the bottom. Therefore, amounts tons per day. Okay, no, this was a repeat. Okay, right on page 6, please. Right on page 6. You will see one question like this. We discussed this last Thursday. You will, not may, see one question like this. This is the one we did not get to do. It says, because remember, we did 2 in class, 1 for office hours, there was 1 by remaining. This was the remaining guy. It says, if f of x is increasing and concave down over the interval a to b, arrange the following in increasing order. Left Riemann sum, right Riemann sum, trapezoidal Riemann sum, and the actual area. Okay, see if this comes back. So we'll make 4 sketches. It says increasing and concave down. Make a small sketch. It should be rising but facing downwards. Check your finger with the board. Okay, it should be increasing and facing downwards. And the trick for drawing Riemann sum is first, just draw 2 parallel lines like that. But for the last guy, just 1. Okay, let's go over left Riemann sum. How do we draw a left Riemann sum again?
You start at the left and move rightwards.
Thank you. Go to the left corner. Miss Parada, for the first guy, it's here. Left corner, and go rightward. Do the same thing here. And that's that first change. Label it. That's the left Riemann sum. Next, we'll do a right Riemann sum. How does the right Riemann sum work again?
Right.
right corner.
Go to the right corner and go leftward. Okay. That's the area of the rectangles. We went over this because some kids asked me this clarification. If you have the curve really curvy, don't draw a curve like that. Okay, that's not a very curvy curve. Make it kind of steep like that. Then you can actually show the trapezoid. You kind of show up. clearly. Okay. So there's trapezoid there, there's a trapezoid there. That's a trapezoidal Riemann sum. And then this is just the actual area, which is integral from A to B f of x dx. Mr. Buhe, how are you doing?
Good.
Okay. Guys, it says arrange these areas in increasing order. So as a tip, first do all the underestimates, then do the overestimates. Which are the clear and the worst, the real small underestimates?
Left Riemann.
Left Riemann sum.
Left Riemann sum, that rectangle area are the smallest. So left Riemann sum is the smallest. Is there another underestimate?
Trapezoid.
The trapezoid.
Trapezoid is below. In case Farada, you say, I don't know what you're talking about underestimate. Can you see you're below the actual area? So that's the trapezoidal Riemann sum. Is there any other underestimate?
No.
No. And then immediately the actual area will show up. Because that's the exact guy. And then finally, which is the overestimate?
The right Riemann sum.
Right Riemann sum. And that's how easy that is. Okay. You had a question like this on yesterday's homework. If you did not get a chance, if I rushed you, if I did not give you a chance to finish this, make sure you finish it today because I'm not assigning homework formally today. Right on page 7. So this mimics that problem where you have to do a lot of algebra. Do this with me. Read it with me. It says, in a sandstorm at Bakersfield, sand is falling on a backyard at a rate modeled by the function f of t, measured in pounds per second, whereas sand is being collected by a machine at a rate of g of t, also measured in pounds per second. When the storm begins, there's 5 pounds of sand in the yard. Okay. Should we set up the problem?
Yes.
Let A of t be the
Amount of sand.
in the yard at time t. And that's in pounds. And A dash of t, which is R of t, equals
F of t minus g.
minus G of t, which is the rate of change.
The amount of sand in the yard.
Measured in pounds per second. And then finally, it says, when the storm begins, there are 5 pounds of sand in the yard.
A of 0 equals 5.
Thank you. All right. We went over this, Ms. Parada, on Wednesday, Thursday. All of you, I'm giving you time to interpret the question. If you can, give me a left-hand side, give me a right-hand side. Read the question, look at every word. Do not rush. Do not speak, do not speak. It said, how much sand fell in the yard over the first 5 hours? So those of you with good skills, you are able to interpret this. It says how much sand fell in the yard. So what are they asking for?
Amount
Is that amount in? Now, yesterday during our study session, I changed the notation. Guys, you like this notation? Can we write amount in? Basically, in the 0 to 5, the first 5 hours. That's easy for you to follow. And then, who remembers from last week? How do we always find the amount in function?
The derivative of the rate in function.
Yeah, say that again.
The derivative of the rate in function.
Do you not mean integral?
Oh yeah. Integral.
Thank you. We take the integral of the rate in function, correct? And which is the rate in function?
F of t.
F of t.
FED. Okay. If you integrate the rate in, you get amount in. If you integrate rate out, you get amount out. Let's plug it in. So this question, actually, I wanted you to do it by hand. By the way, there's no calculator for this problem. So the function is 1/2 radical t plus 4 dt. Okay. So 1/2. Who remembers how we integrate radical non-t? Because there's no formula for it. I'll give you a hint. You should rewrite t plus radical t plus 4 as t plus 4 to the power of
1/2.
1/2, and then use the power rule because it's a line. So it's t plus 4 to the power of.
3/2.
Thank you. You're adding 1 times
2/3.
2 over 3. The 2's cancel. Lower limit.
0.
Upper limit 5. Okay, let's plug it in. Look down. I'm walking you through it. 5 plus 4,
9.
9 to the power of 3 halves, minus 1/3, 0 plus 4.
4.
Okay, let's simplify. From the first week of school, what's the square root of 9?
3.
Cubit,
27.
27, minus, what's the square root of 4?
2.
Cubit,
8.
8.
final is that 19/3.
Mhm.
And we found the amount of sand. Is that pounds?
Yes.
That's how easy it is. So we did it by hand. Is that clear? You had a question like this yesterday. Right on page 8, please. And guys, observe, because we're doing a review, I want the lesson to be good. Can you see I'm chill? I'm not rushing. I'm not like hurrying you up. We're interpreting the question exactly the way it's written. You have one question of every kind on your test. Okay? Read the question with me. We're on page 8. Repeat, page 8. Do not speak. Do not speak. It says, is the amount of sand in the yard increasing or decreasing initially? So if any function is increasing or decreasing, what do we compute?
The slope is greater than
The slope, and it says initially.
8
8
dash.
dash.
A dash.
A dash of 0. Ooh, but A dash is nothing but
RT.
R of 0, which is f of 0 minus g of 0. Is there any, do we have to take derivatives, integrals, or we just plug it in?
Just put in.
Just plug it in. We can do this mentally. 1/2, what's 0 plus 4?
4.
Square root
2.
2 minus g of 0 is just
0.
2.
final answer
1.
1. What would your units be?
Pound.
Pounds per second.
Pounds per second, A dash or R. Let's write a sentence. So the amount of sand, I'm just getting from the question. Guys, I never make up the sentence. I get it from the question. The amount of sand in the yard is
Increasing.
increasing initially since
A dash is 0 is greater than 0.
is greater than 0. Correct? That's how easy that one was. Okay, right on page 9, please. Right on page 9. I want you to start processing the problem. Okay, Miss Julian or Miss Meena. I'm accepting suggestions. What is the question asking for?
It's absolute for the absolute minimum and the absolute.
Okay, so we want the absolute max and min of A of t. Oh, but it's actually amount of sand. That is a typo in the yard. Okay, of A of t. So guys, good habits. What should we always consider?
Endpoints and critical points.
Endpoints
Okay.
are critical.
Consider the endpoints, which are t equal to 0 and 21, and the critical points. How do we always find critical points for any function?
RT
A
is equal
slash
to 0.
0.
The slope, which is A dash of t, which is R of t, should be equal to 0. And is that just f of t, which is 1/2 radical t plus 4 minus g of t, which is 1/6 should be equal to 0. Now I'm showing you the algebra. Okay, look down, look down. So I went over this yesterday. I gave a hint. You want to isolate the radical. So what should I do next time? Algebra.
Add the 1/6.
Add 160. So I have 1/2 radical t plus 4 equals 160. Next step,
Multiply by 2.
if you want to multiply by 2, go for it. So radical t plus 4 equals 130. Now, we've isolated the radical. What should I do to both sides?
Square it.
Square it. Put parentheses. So it's neat. So what does the left hand side become?
T plus 4.
T plus 4. What does the right hand side become?
1/9 t squared.
And then look at the board, please. Can I just put a 1 and cross multiply? Don't freak out. Okay, basic algebra. I can cross multiply. So 9t plus 36 equals t squared. Yes.
Mm-hmm.
I just cross multiply. I distribute it immediately. I skipped a step. Can we move everything to one side?
Yeah.
Guys, is it smart to keep the t square guy, the quadratic term, positive? So I'll move the others to the right hand side. So t square minus 19 minus 36 equal to 0. Do magic X yourselves. Tell me the two values of t. Go. Look down. Use magic X. Give me the two values of t. I hope you have basic factoring skills.
12 and 3.
What's your signs?
-12, +3. T is
So
equal
plug it in.
T is equal
Is
to
t 12 then? T cannot be negative. So it's t minus 3. T equal to -3 is ruled out. Okay, guys, we're not done. What do we do last step with these guys?
Evaluate.
Evaluate. So a of 0. We have time to do only two of these. Okay, we'll do a of 0 and say a of 21. What's a of 0? Ooh, what's a of 0 given to me?
5.
5 pounds. And then hint, we know a of 0. So what's a of 21? Go.
A is 0
Plus
the interval 0 to
from 0 to
21.
21, 3 dash.
A dash of t dt.
And which is nothing but f of t minus g of t, correct?
Mhm.
Let's plug it in. Again, it's to be done by hand, guys. So a of 0, which is going to be 5 plus integral 0 to 21. So I was giving you practice integration by hand. And then it's 1/2 radical t plus 4 minus 1/6 t dt. Yes? Let's wrap it up. 5 plus. Wait a second. Didn't we just integrate this 2 minutes ago? If you look at your notes, I'm doing this from memory. Wasn't that 1/3 t plus 4 to the power of 3/2? Does it come back to you guys? So I can accelerate. Minus 1/6. What's the integral of t?
T squared. That's 2.
I mean over 2. Lower limit,
0.
upper limit.
21.
21.
Okay, let's wrap it up. 5 plus. Okay, let's plug in 21. 1/3. 21 plus 4.
25.
Okay, guys, I'm going to do a bunch of mental things. Okay? Square root of 25.
5, 12.
Cube it.
125.
125.
25 minus 1/6. Can I write that as 112?
Yes.
And then 21 square is 441. And then minus parentheses 1/3. 0 plus 4.
4.
Square root.
2.
Cube it.
8.
And then minus 0, correct? Last step. Look down, guys. Observe. I'm not in a rush. I show every single step. So 5 plus 125 thirds minus 441 twelfths minus 8 thirds. Yes?
Yes.
And on your test, I'm okay if you stop right here. Okay? I'm okay. By the way, I can do mental math. 3 goes to both 12 and the thing. 3 goes 1, 4, 7. 3 goes 4 times. Even simpler that. Now, I am good in mental math, so I can do that very quickly. Anyway, and then finally, I'm not doing it, but should we also evaluate A of 12, was it?
Yes.
Correct? Simpler. Correct? Remember, smart kids, we've done the integration. We didn't have to change the 21 to a 12. Okay, everything remains exactly the same. All right. Next question. Write on page 10, please. Everybody write on page 10. I'll switch to red so you can tell them. Write on page 12. 10, I meant 10. Interpret this exactly the way it's written. Do not speak. Use the notation I just taught you. It says, how much sand did the machine collect in the first 4 hours? Feel free to scan the problem again to see what they're talking about. Okay. how much sand does the machine collect? Okay, those of you got the hang of it. What do they want?
Amount in.
Amount out.
Amount out.
Amount out, correct? Mr. Rango, collect is the amount out. Yeah.
My bad.
Okay, the amount out from 0 to 4.
Yeah.
And how do we find the amount out?
Integral.
Integral 0 to 4 of the rate out function, which is
G.
g of t dt. Mr. Rango, don't feel bad. I understand why you said amount in, because you thought collect means in.
Yeah.
I get it. But it's smart to look at the question to see, hey, what's the language? So the previous one, it said how much sand was falling. You say, oh, falling is in.
Yeah.
And here, collect
No.
out. Scan the problem from the context to see what's going on. Okay.
Okay.
Let's move on, guys. Right on page 11. It was a simple integral, so we already integrated earlier. Okay? This is from the first semester. I'm tying up concepts. So it says find and interpret the value of f of 32 minus g of 32. Woo! F of 32 minus g of 32 is nothing but
A dash 32.
r of 32, which is a dash of 32,
Yes.
which is guys, we need f of 32 minus g of 32. Do we have to take the derivative, integral, or just plug in?
Just
Just plug it.
Just plug in. We can do a little bit of mental math. 1/2. What's 32 plus 4?
36.
36.
So what does it become?
6.
6, because square root, silly. It's a square root. Minus and 1/6 of 32. 2 goes 3 times, 2 goes 16 times. Final answer?
-7/3.
Look at your units. Hint. It is R or A dash. What would your units be?
Pounds per second.
Pounds per second. Let's write an interpretation. Now, in case you've forgotten how interpretations are done from the first semester, look at the board, please. Remember, we look at the base with the guy with the derivative. Okay. Indicates that at t equal to
32.
seconds. I'll give you two options. Choose wisely. Do we say the amount of sand is increasing or decreasing, or the rate of change of the amount of sand is increasing or decreasing?
The amount.
The amount. Very good. Smart. So you look at the A with the guy in dash. Look at the base, which is A. The amount of sand. Again, always look for the base of the guy with the derivative notation in the yard. Is increasing or decreasing?
Decreasing.
Decreasing.
Okay. At the rate of positive 7 pounds per second. Next page, right on page 11, please. Right on the question. And what's f dash of 12 minus g dash of 12?
A double dash of 12, which
A
is
double dash of 12, which is nothing but r dash of 12. Why is that important? Because look at your base with the guy with the first derivative in your interpretations. Guys, I'm writing derivatives, integrals, or plugging it in. Hint, I need f dash of 12 minus g dash of 12.
Derivatives.
Derivatives, okay, 1/2. Okay, from the first semester, what's the slope of radical monkey?
1/2.
1/2 radical.
2 radical monkey times 1, right? Minus, what's the slope of 1/16?
1/6.
Just 1/6. Slope of t, which is x, is just 1. And then final step, are we plugging in 12?
Yes.
Okay. So that's 1/4. And then 12 plus 4 is 16. Square root is 4. Oops, sorry. Is that 1/16 minus 1/6? Now I'm informing you, your LCM is 48. Okay, 16 goes 3 times. 6 goes
8.
8 times. So is that negative 5/48? Careful. What would your units be? Hint. This was R dash of 12.
Pounds per second where?
Square. Okay, let's do interpretations from the first semester. Indicates that
At t
t
equals
equal to 12 seconds. Okay, look at the base of the first derivative. So do we say the amount is increasing or decreasing, or the rate of change of the amount is increasing or decreasing?
The rate of change.
Rate of change.
The rate of change of the amount of sand in the yard is decreasing
Yes.
at negative, oh, positive, don't write negative again, at 5/48 pounds.
Wait, Rama, where'd you get 1
Yes.
over 16?
Say that again.
Where'd you get 1 over 16?
I'll write in red so you can see. We're plugging in the 12. What's 12 plus 4?
16.
Square root
4.
times this 4.
16.
So 1 over 16.
Oh.
So we actually did it. We didn't just stare. We actually simplified it. Okay. We'll skip this page. Go to page 14. Please. Everybody go to page 14. So we'll only set up the problem. Okay, we'll only set up the problem. We'll just calculate a problem. Read the question with me. So it says, now guys, I strongly recommend, because we're not having homework today, please do attend office hours. Okay, just do attend office hours, and then attend office hours tomorrow, and then you'll take the test on Thursday. Okay, it's a fairly straightforward test. Okay, if you're comfortable in the homework, comfortable in classwork, you should be fine. By the way, Carlos, Vasquez, how are you chaps doing? My favorite girls, how are you guys doing? I haven't even spoken to you today. Carlos and Vasquez.
I'm doing good.
Okay. Carlos?
Yeah.
Okay.
Oh, I said I'm doing good.
Oh, okay. Vasquez? Okay, guys, Vasquez is super adorable. She does her homework at 2 a.m. Okay, moving on. It says the amount of strawberries on display at a store is changing at a rate of ROT in pounds per hour. It's true, Vasquez. I look at your time because I'm awake. Anyway, if initially there are 12 pounds of strawberries on display, find the amount of strawberries at t equal to 3 minutes. So let A of t be the amount of strawberries. On display. And that is measured in pounds. And at R of t, the A dash of t is the rate of change. And then they say, guys, read this paragraph. How do we interpret this guy?
A of 0 equals
Okay, 0 equals 12 pounds. And the question says, find the amount of strawberries at 3 minutes. Oh, that's a typo. That's supposed to say hours. Okay? Okay. So both are in hours. So you don't, those of you reading it carefully, saying, hey, that's pounds per hour. How can it be 3 minutes? So we need A of 3, guys. How do we just find it? Ms. Bishop or Ms. Uduman? One of you can answer.
A of 3 equals A of 0 plus integral 0 to 3 R of t dt.
Thank you. Guys, can you hear me?
Yeah.
yes.
Okay. Because my other computer I lost. Can you hear me?
Yeah. Yes.
Okay. And what's A of 0 given to me?
12.
12 plus integral 0 to 3 is R of which was t cos et dt. And you can plug this into decimals. Everybody okay then?
Yes.
Scroll down to page 15, please. You will see one question like this. Not may, you will. Sketch it. I'm giving you 30 seconds. Sketch it. Okay, by the way, this is f dash of x. Okay, label that. Read the question. It says if f dash is depicted below, you have a question just like this. Find the value of f of -4 minus f of 3. Look at the board, please. Is there a mismatch?
Yes.
Correct? So we can rewrite f of -4 minus f of 3 as Ms. McWhorter or Ms. Bergen. You can, either of you can answer. Equals, go. Again, Ms. Bergen or Ms. McWhorter.
Integral 3 to -4.
Love you. Guys, it's tempting to write -4 on the bottom. No, the negative guy is at the bottom. Okay, 3 to -4, go.
F dash of x dx.
That better be Bergen.
Yeah, it is.
I'm kidding. The reason I said that is because I'm identifying a voice. I'm not able to see her right now. My other computer just shut down. Anyway, so guys, long story short, is that just the area under the curve? Yes.
Yes.
Okay, so let's find the area. It says from 3 to -4. So old rules, I'm going to drop the perpendicular. That's 3. And then -4 is here. -1, -2, -3, -4. It's here. Correct? So I need the area under the curve. All right. Now this one, I'm just going to accelerate. Now technically, I need to find the equation of that line and plug in -4. Yes?
Yes.
Now this particular one, I'm just going to eyeball because it worked out well. So that guy is -4, 1. Is that clear? Okay, find all the areas yourselves. So what will that first triangle area be?
1.
1. Base is 2, height is 1. Half base times height is 1. Now that's a semicircle. So hint, semicircle is half a circle. So what's the area of half a circle?
Pi r squared. 2 divided by 2.
Which simplifies to?
2
Pi.
pi.
Is it pi or 2 pi? Hint, it's a semicircle, not a quarter circle.
No, it's 2 pi.
2
It's
pi.
2 pi, correct? It's 2 pi. Then what's the area of that other triangle?
1.
Is it 1 also? Okay. Finally, guys, I'm going to write the final answer. Be smart and correct me. Everybody, I'm in a rush. I'm kind of mimicking you. Okay, I'm kind of teasing you or mocking you, some of you. So I'm mimicking you and I'm mocking you. I'm rushing and doing the problem. I'm going to make a mistake. Correct me. Be smart. Okay, so that's 1 minus 2 pi plus 1. Final answer, 2 minus 2 pi. Okay, smart kids, correct me.
-1. Put
Negative 2 pi.
plus 2 pi minus 1.
Very smart. Why? Where? Correct me. Where was I being careless? Or why am I being careless?
Because it goes
You're going right
3 to 4.
Very, very smart. Love you. Everybody, look at the direction. The most common error kids will make, even smart kids, is they're rushing. It goes from 3 to -4. So look at the direction of the arrow. From 3 to -4. So this is wrong. So it's really -1 and then plus 2 pi. We're below, but we're going right to left. And then -1 again, correct?
Yes.
So final answer, -2 plus 2 pi. It was exactly the opposite sign. Slow down, please. Okay, right on page 16, please. Right on page 16. It is exactly the same problem. So write down the given information. They say this time f of -2 is 5, and they say find f of 5. Mr. Buhe, have a shot. Unmute yourself. If you're incorrect, I'll guide you. Observe what's given and what's asked. Go.
F of -2 plus integral -2 to 5 f dash of
Love
t.
you, man. Dx.
Oh,
Okay.
yeah.
It's okay. Guys, what's f of -2 given to me?
5.
5 plus. Do I just need the area from -2 to +5? Okay. From the previous thing, relax. Just use the same figure. That guy was 2 pi, correct? And this guy was 1. What's the final? This is 5, by the way.
6 minus 2 pi.
No. I just wanted the area of the final triangle. You're going way too ahead. I just want. So I'm breaking down the problem. So what's the area of this guy?
Oh, that's 2.
2, correct? Can we write down the answer? So 5 plus. We're going left to right, right to left.
Left to right.
Left
So what am I writing?
5 minus 2 pi.
minus 2 pi
Is that -2 pi?
plus 1.
Plus 1 minus 2.
Why -2, silly?
Yeah, my bad.
What are you doing? Plus 2. So absolute final answer. Is it 8 minus 2 pi?
Yes.
Yes.
Okay. Slow down. It's an easy problem. Don't make sign mistakes. All right. We will not do this guy. I want to spend time doing a harder problem. This is a brand new problem. Take 30 seconds, make a rough sketch. So it is a squiggle graph. This is a squiggle graph from -1 to 2. There are some kids on yesterday's session who were lost on this problem, so I want to go over this. It's actually quite easy. Again, don't freak out, it's an easy problem. All right. Now read the question with me. I hope you've made a sketch. Label it. Okay. Read the question with me, please. It says the graph of g of x is given above. Over the interval -1 to 2, are you able to spot it? From -1 to 2 only. G of x can be depicted by the function x cubed. So they're telling you guys this guy is x cubed. Is that clear?
Wait, so that's supposed to be g of x instead of f of x? Or?
No. It's okay. It's okay. It just says g of x can be depicted by the function f of x equals x cubed.
Oh, okay.
In that interval. Okay, I'm just breaking down the problem. So that in that interval, from -1 to 2, that function. But what I'm saying, was that you, Lopez? What they're saying is the whole function is g of x, but in that interval, that particular sketch is x cubed. F of x equals x cubed. Okay.
Okay.
There's nothing to freak out. It's just a notation thing. Okay. Let's read the question. It says find the average of g of x from -4 to 8. Okay. How do we interpret the problem? Find the average of g of x from -4 to 8. Go. 1 over
12.
integral
-4 to 8.
and
Gx.
then g of x dx.
X.
Okay, stop. In simple language, everybody, don't freak out. In simple language, do we just need to find the area under the curve from -4 to 8? Yes?
Yes.
Yes.
So, if we have a figure, good habits. Should we draw perpendiculars? Sharp corners, endpoint? That's all I'm going to do. Do not freak out. So I'm going to draw the perpendicular there, there's a sharp corner, here, and then here. Yes?
Yes.
Is everybody okay with what's going on? I'm just following the regular rules. Okay. So 1 over 12, bracket. Okay, what's the first area? Go, do that yourself. We're going left to right. In simple language, I want to find this area. Tell me what that area is. It's just base times height.
3.
3? Careful. Is it 3 or -3?
-3.
Because we're going left to right. Everybody okay there? So -3 plus. Okay, now I need the area from -1 to 2. So smart kids, what should I just do?
Is it integral?
The integral. I love you. So I just need to find the integral from
-1 to 2?
-1 to 3 of which function?
Oh, to 3. Yeah.
Oh, -1 to 2. Sorry, -1 to 2. And what is that function given to me?
F of x.
Which is
It's cute.
Which is
q.
Mhm.
Everybody okay there? Plus, and what's the area of the right wing? Do that yourself. Just look at it. What's the area of the right wing? What's your base? What's your height? How much?
32.
Is that 32? And positive, correct? We're going left to right. So long story short, everybody look at the board. You observe we had like a piecewise function. We broke it up into a rectangle, curve, and a rectangle. For the rectangles, we just did base times height, and with the curve, we integrated. Do you see what happened? There's no reason to freak out. We just broke down the problem. Okay, let's wrap it up. 1/12. What's -3 plus 32?
29.
Is that 29?
Mhm.
And then what's the integral of x cubed?
1/4 x squared.
Lower limit,
-1.
upper limit,
2.
2. And then final. So 1/12, 29. What's 2 to the power of 4?
16.
Divided by 4?
4.
Okay, I'll write the 16/4. Minus parentheses. What's -1 to the power of 4?
1.
So that's 1/4. Is the rest of it just simple algebra?
Yeah.
But the most important thing is me marking in red. Everybody look at the board in red, saying, "Oh, so that concept was important." I just didn't need to freak out, which is this step. Okay, I had a rectangle, I had an integral of a function, and then a rectangle. Is that okay? I just broke up that integral. I just split up that integral. Don't freak out. All right.
Rama, where did -4 to 8 come from? Because I know the graph stops at 6.
Oh, sorry. Oh, no. The graph starts at 6. Oh, you're right. Guys, Abdul Rahman points out an error. That's supposed to be 6. I'm so sorry. That's a typo. I'm an idiot. Oh my God, I feel so bad. Abdul Rahman was like, so in math, there's a rule. Every time they give you a 6, I need to add 2 for some reason. I need to make a 6 and 8. There's that rule. I had bad teachers. My lower level teachers did not teach that trick at all. But Rama, I'm so glad I have Rama. So he showed me, he opened my eyes to the rule. When it says 6, I should just write on 8. So guys, I'm teasing Abdul Rahman. I'm extending the gag. So Abdul Rahman is working at McDonald's. And the person says, so how much do I owe? Some person says 68 cents. And Miss Abdul Rahman says, you mean 88 cents? Because the 6 is an 8. I'm like, what the hell? Okay, yeah. So there's just a typo in the problem. It was supposed to be a -4 to 6. So it'll be 1/10 then, okay? But the algebra, rather, the concept is more important, correct? But thank you for pointing out that error, okay? Let's go to, right on page 20, please. No, actually, we'll do this in office hours. Right on page 21, please. Everybody, 21. Write down this function. I've underlined anything and everything that's relevant. Guys, this is a calculator problem. Okay, we'll just set it up and then the calculator will handle it. Okay, who, if anybody, please memorize your formula sheet. Every day I send a formula sheet. Who remembers the formula for distance?
Absolute value.
Integral from 1 to 4.
Absolute value of v of t.
Absolute value. Love you, Taran. Absolute value of v of t. Everybody okay there? And I'm going to plug it in. 1 to 4. Absolute value of 2 sine. Now remember, don't freak out. It is a calculator problem. Now, because we haven't done a calculator problem involving absolute values, let's actually do that right now. I'm in no rush. Everybody, let's actually do this. I want to show you how Desmos works. They have asked AP questions like this. So switch to Desmos. Now, guys, this is Desmos. So Desmos will handle all the hard work. Is that clear? So integral, lower limit,
1,
upper limit,
4,
4, right arrow, absolute value. Hint, the absolute value symbol is above enter, below backspace. It's above the key that says backslash, okay? And then what is the function again?
2 sine,
2
sine,
sine
and then e to the
e
power of,
t minus t or something,
yeah.
and then come outside, everybody. Come outside and then write dt, yes? Oh, I should have written x, but I think I may be okay. Dt, yeah, I may be okay, yeah. Write down the answer, 3.8222. I rounded to 19. But I want you to observe that in Desmos, now before I leave, everybody look at Desmos. I'm going to blow your minds. Now, if this was a hand problem, everybody, if this were, we were doing this by hand, I'm jogging your memories. If we have an absolute value, look at the board, please. Who remembers if we are doing this by hand, if I had an absolute value, what should I find first then?
X-intercept.
Love you. She said, I need to find the x-intercept. But can you see, but Desmos takes care of everything. You don't need to break it up. That's what I'm blowing your mind about. In Desmos, you don't have to find the x-intercept, none of that stuff. Plug that in, you're good to go. And that was 2.82222.
That's
Yeah.
Was that the answer?
2.
Okay.
3.8.
3 point? Okay, and that was it. I was showing you how to type that into Desmos. Put absolute value and the function, Desmos will take care of it. If you had a calculator, your calculator will handle it. Okay. Right on page 22. But please study your formulas. You're not given formulas on your chapter test or on the AP exam. Okay, do not speak. Okay, what's the formula for displacement? Miss Carlos or Miss Vasquez? You can answer, one of you.
S of 3 minus S of 0.
Okay, S of 3 minus S of 0. Do we have a mismatch?
Yes.
So, next step.
Integral 0 to 3 that's dash of t.
And what's this dash after all?
V of t.
Okay, so integral from 0 to 3, V of t. Guys, but I encourage you to memorize that integral directly, yeah? Morales, stop barking.
It's not
Okay.
me. It's not me. I swear.
You're not barking?
No, it's a dog from like outside of my window.
Do you want to shut the window?
Yeah.
Okay. All right. Guys, we will not do it, but did everybody understand the concept? So you integrate this velocity without absolute value, and that's displacement. I want you to memorize that, please. The integral of velocity without absolute value is displacement. Okay. Because we're going to do 23 together, all of it. We're going to do 23 together. How is 23 different from 22? Because they look identical.
It's distance traveled.
It's distance this time. And this will do by hand. Okay, not by Desmos. Okay, what's the definition of distance again?
It's absolute value of
V of t.
Absolute value V of t.
Okay. Which is integral 0 to 3. Absolute value t square minus t minus 2 equal to 0. Oh, sorry, dt. Okay, now let's discuss that idea. How do we find integrals of absolute value functions? I'm asking one question like this on your test, but it'll be an easy one. Should we find the x-intercept? Remember that process, Miss Carlos? So t square minus t minus 2 equal to 0. Which is your relevant root.
Two.
2. Okay, it cannot be -1 anyway. So let's break it up. So absolute value, see if that comes back. So the absolute value from outside. Integral from 0 to
2.
2 t squared minus t minus 2 dt. Absolute value plus absolute value integral from
2 to 3.
2
2
to
to
3.
3.
Thank you. T squared minus t minus 2 absolute value dt. Okay. Let's integrate. Look down. Absolute value. If you write the absolute value correctly, every time you'll not make typos. Like, oh my God, I forgot to write that. Okay. Integral of t squared.
T
T
cubed.
cubed over 3
Minus integral of t
T squared over 2.
squared over 2.
minus
2t.
2t. Very good. Lower limit
0.
0, upper limit 2
Mhm.
plus integral. The integral is already there. T cube over 3. We can accelerate that. T squared over 2. Look down. Lower limit 2, upper limit 3. Absolute value. 2 cube,
8.
2 square
4.
over 2. 2 times 2,
4.
4. Minus, is that just 0?
Yes.
Okay, let's just simplify that. Run ahead. What's 4 over 2?
2.
So is that 8/3 minus 6,
Yes.
which becomes, careful, fraction trick,
Negative 10 over 3.
negative 10 over 3. Absolute value?
So it'd be 10 over 3.
There you go. Now you'll understand why we write absolute value in every step. So that guy was below the axis. So 10/3. Let's do the other guy. Plus 3 cube
27.
over 3. Do not simplify. So we have like terms. 3 square
9.
over 2 minus 6 minus parentheses. 2 cube
4. 8.
2 cube
Over
8/3 minus 2 square 4 over 2 minus 4. Okay, let's do like terms. Plus, what's 27/3 minus 8/3? Is that 19/3?
Mhm.
Negative 9/2? Minus 4/2 or plus 4/2?
Plus 4 halves.
Plus 4/2. Is that negative 5/2?
Mhm.
And then negative 6
Plus 4.
plus 4. Is that minus 2? Okay. Guys, let's take LCMs. What's your LCM of 3, 2, and 1? Is that 6?
6, yeah.
Yes.
Don't be lazy. Don't be lazy. Actually do it. And 19 times 2 is 38 minus 15 minus 12, correct? Over 6. Simplify that. Tell me what you got. Go.
$11 over 6.
Okay. Absolute value would be 11/6. And absolute final answer. Can we take LCMs again?
Mhm.
Is that 31/6?
Yes.
The more you do yourselves, the better off you'll be. So I was showing you a deliberately challenging problem. I will not give one like this, but I was showing you the general concept. Like, can you see how it works? Is that clear? Don't freak out. So we deliberately did a challenging problem that involved lots of steps. Okay. Now we'll accelerate. Go to page. Okay, 28, please. Everybody jump to 28. We're almost done. Jump to page 28, please. Read the question with me. Read the question with me. Actually, this should say the typical. Okay, read it with me. The typical monthly temperature for a town in Oregon is modeled by the function f of t, where t denotes the month. And the question says, find the average temperature of the town over the first 6 months. It's a Desmos problem. I just want to set it up. Okay, go.
AV equals
1/6. Integral 0 to 6. And then f of t dt.
Thank you. Is that stupidly simple? So on Desmos, you can type that in. We're not doing it. I'm just showing you. Type that in very carefully. Use X and just type that expression in. Next step. Okay. I encourage you to type out the function first, and then you could plug it in. Is that clear? It's easier that way. Let's